Throughout the 18th century, electricity was considered a fantastic wonder. It sparked the imaginations of intellectuals, inventors, and scientists, often called electricians for their interest in this fantastic phenomena. The 18th century most notable discoveries and inventions included Francis Hauksbee's static electricity generator, Alessandro Volta's Voltaic pile that was able to provide continuous electric current, and Humphrey Davy's arc light, a spark generating system that could light up a whole room for a short time. These and other experiments brought us to the beginning of the 19th century with several important insights about electricity. We could understand that it moved very quickly from one place to the other. We saw that it remained confined to certain materials and stayed away from others. We called them conductors and insulators respectively, and we already had several ways to generate it. At this point in time, no one would even dare to imagine that within 100 years, this newly discovered force of nature would completely change the way we use and transport energy, the way we communicate, and that it would drive to the invention of the modern computer. Going into the 19th century, messages were sent just like any other commodity, by train, ships, or simply over horseback. Transatlantic messaging took weeks and sometimes months. It was becoming clear that electricity might be a good candidate for sending signals, as it moved quickly and was confined to conductors, but trying to do so at the beginning of the 19th century had one major issue, and it was identifying the weak electric signal as it arrived. Then electromagnetism came into the picture and changed everything. Electromagnetism was first observed by Hans Christian Ørsted in 1820 and developed into the electromagnet by William Sturgeon. But it was Joseph Henry who turned it into a practical device, the electric relay, in 1835, giving way to the development of new and innovative detection devices and communication systems by enabling devices that could not only detect but also trigger the activation of another separate electric circuit. Communication systems that relied on these new inventions appeared and their use gradually expanded. One such system is the Morse telegraph that used electromagnets to create ink markings on a moving strip of paper, but it was the COOKE and WHEATSTON telegraph to become the first commercially used telecommunication system. It was used for signaling between railroad stations in England. Its receiver consisted of needles that were connected to electric magnetic coils. It was designed to minimize the number of lines needed to connect the stations, so the combination of needles was used to point to different letters, and not all letters were supported. It should not surprise you that by 1860, a transatlantic submarine line was laid and operational, and that message delivery that used to take weeks now took a few minutes. When it comes to energy distribution, at the beginning of the 19th century, we were in the midst of the Industrial Revolution. Factories were run by a central steam engine. Streets and houses were lit by gas and oil lamps. Vehicles such as ships and trains were operated by coal. The main issue was that if you wanted energy, you had to have a fire running and a continuous supply of coal, gas or oil. And that wasn't convenient. We needed a better way to distribute our power. If I had to choose just one scientist and inventor in regards to this revolution, it would definitely be Nikola Tesla. Two of his 19th century inventions, the AC power generator and the AC induction motor, were the two crucial components for a new revolutionary energy distribution system. A system in which the fire is running in just one central place, steam is generated, and the energy is converted into electrical energy. Electric current can then be easily distributed via conductors and transformed back into kinetic energy using Tesla's induction motors wherever needed. Factories now did not need a central steam engine and were not limited by a central moving axle, but could have separate machines with their own induction motors and electric lines. The computing revolution started only at the beginning of the 20th century. During the 19th century, mechanical computing systems were gradually improved, culminating with Dr. Eugene Felt's COMPTOMETER in 1887, a key-driven digital machine that could perform all 4 arithmetic operations. Much more complex digital machines were designed at the same time in England by Charles Babbage. Charles's analytic engine introduced novel ideas to the mechanical computing world, such as printing results, storing results for later use, and most notably, performing operations based on intermediate results. Unfortunately, his ideas were not carried out due to financial limitations, and what you are seeing here is a reconstruction of his design done at the London Science Museum. Mechanical computers were not all digital. Very advanced analog mechanical computers were built in several places. The most notable is probably Vannevar Bush's differential analyzer computer in MIT, capable of solving differential equations, but also various analog computers designed to perform specific military tasks, such as the Torpedo data computer that was designed to solve the problem of hitting a moving vessel from a moving submarine. At the beginning of the 20th century, an English mathematician named Alan Turing formulated all the 19th century know-how from mechanical computing into the baseline of the modern computer science. And when this was integrated with George Boole's ideas on Boolean algebra, 3 different scientists from 3 different places used the newly invented electric relay to come up with the first electromechanical computing device. These new pioneering computing devices used electric relays first and later vacuum tubes to perform binary calculations, but also control functions. These scientists were George Stibitz from Bell Labs, who built his first prototype on his kitchen table and therefore called it Model K. The other 2 were Konrad Zuse, who developed the Z3 prototype and continued with the other Z-type computer family in Germany, and Howard Aiken from Harvard. Once these first prototypes were designed, the revolution was on its way. Given a big push by Second World War, the first full-scale electronic computers were designed. In England, the Colossus was built and used to decipher the German Enigma, and in the States, the ENIAC was completed towards the end of the war, becoming the world's strongest computer and most complex electronic system. From here on, the computing revolution continued, improving both the hardware and the software, until today's gigahertz speed silicon-based computers. Electricity was a truly disruptive technology during the 19th and 20th centuries, and it's responsible for some of the biggest revolutions we've seen during this time. If you want to learn more about these revolutions, click the links below. Don't forget to subscribe, and thanks for watching.